Section 1.3, part 2. Solve each equation for x. Find any restrictions. What's a restriction? Well, what we want to do is identify what variables are in the denominator at the beginning of the problem and at the end. And we want to identify what makes those variables become zero. And we don't want to allow them to become zero. If they become zero, the equation then is undefined and you can't find the solution to the problem. So the first thing we want to do is actually solve the problem and check for the restrictions at the end. Number one, here I have three variables, x, k, and z, but x is the one I'm solving for, and we're going to treat k and z just like constants. I want to get my variable term alone, so I'm going to add 5 on both sides. That leaves me x over k equals z plus 5. I want to get my coefficient on the x to be a positive 1. K is dividing that x, so I'm going to multiply on both sides by k. The k's cancel on the left, leaving me x. And on the right, k times the quantity of z plus 5. I can also use the distributive property and get kz plus 5k, but this is simplified enough. Now we have to check for our restrictions. On our solution, we have no variables in the denominator, so there are no restrictions at the end of the problem. But at the beginning, I have a k in the denominator. And what will get k to be 0 is 0. And therefore, my restriction is k cannot equal 0. Number 2, a negative 4 plus x over 3 equals m. I have two variables, but x is the one I'm solving for, so I'm going to get that variable term alone by adding 4 on both sides. That leaves me on the left x over 3 equal to m plus 4. 3 is dividing x, and I need this coefficient to be a positive 1, so I'm going to multiply both sides by 3. That gives me 3 divided by 3, which leaves me a positive 1x. And then I have 3 times the quantity of m plus 4. I can distribute to get 3m plus 12, but this is simplified enough. Both are acceptable. Now we have to check our restrictions. Our solution has no variables in the denominator, so I have no restrictions here. And up here, I have no variables in the denominator. So on number 2, there are no variable restrictions. Number 3. Again, I have 3 variables, but I'm solving for x. I want to get my variable term alone, so I'll subtract k on both sides. When I do that, I get x over n equals m minus k. I'm going to multiply both sides by n. That will give me n divided by n, which leaves me a positive coefficient of 1 for my x, and n times the quantity of m minus k. I can use the distributive property and get nm minus nk. Now we have to check for restrictions. My solution have no variable in the denominator, so there's no restrictions for my solution. But my beginning problem has x over n. N is in the denominator. And we can just set n equal to 0. And that makes my variable equal to 0. So I just have to disallow that by saying n can't equal 0. If it did, that would make my problem undefined. Number 4, mx plus nx equals k. Recall that I'm solving for x, but here x is in 2 terms, but these 2 terms are unlike terms, so I can't combine them and then divide out to get a coefficient of a positive 1. So what I want to do is use the distributive property. And in the distributive property, the common term in each has to come out front. And that leaves me x divided by x, m, plus x divided by x, n. And I can check that I'm right by taking x times m, which is mx, and x times n, which is nx. In further chapters in Algebra 2, we're going to call this factoring. Let's continue with the problem by setting that equal to k. And now what is multiplying my term is this m plus n, or this group. So what I want to do is divide both sides by that group, or m plus n. Then the groups cancel on the left, and on the right I am left with k over m plus n. I still have to find my restrictions. In my original problem, I have no variables in the denominator. Therefore, I have no restrictions here. But on the bottom, I do have restrictions. If I let m equal 0, n can still be any number and the problem is solved. If n equals 0, m can be any other number and the problem is solved. But recall, I need to make sure that the denominator is not 0 itself. So what makes m plus n equal to 0? Well, if I solve that, that tells me that it is going to be 0 when m equals a negative n. So if this was 2, and this was the opposite, or a negative 2, 2 plus a negative 2 would make this quantity 0. If this was a negative 5, the opposite would be a positive 5, and that would still make the denominator 0. So m cannot equal its opposite of a negative n. Number 5, very similar to number 4. I have x that I'm solving for, but it's in two terms that are not common. So what I'm going to do is, again, use the distributive property, or as we said earlier, factoring. That leaves me a minus b, and I can check that x times a is ax, x times b is bx, and that equals c. Again, what's multiplying my x is a minus, so I'm going to divide by that on both sides. And that gives me x equal to c over a minus b. Again, I have to check my restrictions. On number 5, there are no variables in the denominator on the original problem, but there are on the bottom. Again, a itself can be 0 as long as b is not 0, and b itself can be 0 as long as a is not 0. But what makes that whole group 0 is if I set it equal to 0 and then solve. So if a equals b, or I add b to both sides. If a equals b, then my whole denominator becomes 0, and my problem becomes undefined. So therefore, I want to say a cannot equal b by a restriction. Number 6, I'm still solving for x, and x is in a quantity above my 3. So 3 is dividing that quantity. So what I want to do to simplify this is to multiply both sides by 3. And 3 divided by 3 leaves me 2x minus 1. And then I'll use the distributive property, which is 3c plus 3d. Then I'm going to add 1 to both sides to get my variable term alone. That gives me 2x equals 3c plus 3d plus 1. Now, to get the coefficient to be a positive 1, I'm going to divide by 2. And my solution is x equals 3c plus 3d plus 1 over 2. Now, for restrictions. In the original problem, I do not have any variables in the denominator, and in the solution, I don't have any variables in the denominator, so I have no restrictions on problem 6. Our next problem. The formula for the surface area of a rectangular prism is to be A equals 2 times the quantity of LW plus LH plus WH, and they want us to solve for W. Our variable that we're solving for is buried inside our quantity, and they're unlike terms. So let's simplify by distributing the 2. So that gives me 2LW plus 2LH plus 2WH. I want to get rid of my LH on the right side to get my variable terms alone. So I'll subtract by 2LH on both sides. And that gives me A minus 2LH. And that equals 2LW plus 2WH. I'm solving for W. And this is very similar to our previous problem, where I can take my W out, like the distributive property, and that would leave me with 2L plus 2H. What's multiplying my W is my quantity of 2L plus 2H, so I can just divide by that. And that gives me A minus 2LH over 2L plus 2H, and that equals W. Our next problem. Tom wants to use part of a garage wall as one of the long sides of a rectangular pig pen. He wants the pen to be 3 times as long as it is wide. He has a 68-foot of fence, and they want to find the dimensions of the pen. Well, if this is our garage, and here's our pen, recall that the garage wall is going to be the long side. Now, in word problems like this, I always ask 2 questions, and it's going to come from this part of the problem. And the 2 questions are, what 2 things are we talking about? Well, he wants the pen to be 3 times as long as it is wide. So we're talking length and width. So what are we talking about? Length and width. Which one of these do I know least about? He wants the pen to be 3 times as long as it is wide. Well, I know the least about the width, so that's going to be my variable for x. And what is the length compared to my width? It is going to be 3 times as long, so that is going to give me 3x. So my long side is 3x, and my 2 short sides are x. I know that he has 68 feet of fence to cover that amount of area. So what I need to do is see how long this is. Well, that's going to be x plus 3x, and he's going to use 68 feet of fence to do that. That gives me 5x equals 68. Divide by 5 on both sides. And when I divide, I'm going to get 13.6 feet for x. So my widths are going to be 13.6, and the length is going to be 3 times that amount, which is going to give me 40.8 feet. Our next problem. The sides of a quadrilateral are in the ratio of 1 to 2 to 3 to 6. The perimeter is 138 inches. Find the lengths of the sides. Here, when we're solving problems involving ratios, we want to let the ratios be the coefficient of a common variable, x. Well, if x is my common variable to each, and these are my coefficients, then I have 1x, 2x, 3x, and 6x. And when I'm finding the perimeter, that means I'm going to find the sum of the sides, and our perimeter is equal to 138 inches. So now I just combine like terms, 1, 3, 6, 9x is equal to 138 inches, and then I'm just going to divide both sides by 9. And when I do that, I'm going to get 15.3 inches with a bar. Now, I just substitute back into each one of these quantities, and I'll determine the lengths of each side of my quadrilateral. And after substituting, these are the values I get for the lengths of my quadrilateral. Our last example, a jet leaves an airport and flies east at a speed of 350 miles per hour. 35 minutes later, a second jet leaves from the same airport and flies east at a higher altitude but at a speed of 400 miles per hour. How long does it take the second jet to overtake the first jet? Well, what we're talking about here is distance problems. Remember, the formula is rate times time equals distance. Well, we know the rate of each. The first plane, P1, its distance is going to be at a rate of 350 miles per hour. I don't know how long it's been in the air, so I'm going to call that x. Remember, it's the one I know least about. The other one has been in the air 35 minutes less. So 350x, rate times time, equals our distance, which is going to be determined. That's what we want to find. P2 is going to be the second plane, and that's flying at a rate of 400 miles per hour, but it's left 35 minutes later than the first plane, or it's actually going to be 35 minutes behind or less flying time, and I'm going to do that with 35 over 60 so it can be in the terms of an hour, and that's going to be a distance. Now, what do we know about these two planes? P1 left and then P2 left a little bit later, but at some point, since it flies faster than the first plane, their distances are going to be equal. So we can set these two values equal. 350x equals 400x minus 35 over 60. Now we can just simplify the problem. 350x equals, using the distributive property, 400x, and then 400 times 35 over 60 is going to give me 233.3 with a bar, and that's a minus sign. Now, what I want to do is get my variables in the same side, so I'll subtract 400 on both sides, 400x, and that leaves me a negative 50x equal to a negative 233.3. Then I'm going to divide both sides by a negative 50, and x is going to equal 4.6 with a bar hours. But they wanted to know how long it took plane 2 to overtake the first plane. This plane was in the air for 4.6 hours. Plane 2 was in the air for 35 minutes less than that. So I need to subtract 35 minutes from 4.6 hours. But 35 divided by 60 is going to equal 0.538 hours. So we're going to subtract that from 4.6 hours, and I get 4.13 hours.